Okay, diving into 4, talking about congruent triangles. Congruent triangles have the same size and shape. They're exactly the same. Okay, think about a congruent triangle. They're equal to each other. Okay, they're not similar. Similar triangles are a different thing. We're not going to really talk about those very much. But congruent triangles, that's if I take a triangle, I literally copy, I paste it. I would have the same image, same exact triangle. Maybe this one is turned a little bit more. It's still the same thing, right? If you have 2 quarters and you have Washington's head facing upwards, you take the second quarter and turn it so Washington is upside down now. It's still the same quarter. That's what we're doing here. We just need to maybe use our brains in a different way to think about moving that shape or matching that parts to find which parts of this thing match. So, congruent triangles are the same size and shape. That means all the angles and sides are the same, okay? They're gonna match each other. So, take a look at this picture. It might be a little overwhelming because there's lots of little lines, lots of little dots, but really those are there to help you. So focus only on the angles, only the corners right now. You see how A only has one little line? Well, that's gonna match the corner over here that only has one little line. A matches with D. And I knew that over here because A was the first one and D was the first one. And here it tells me B is the second one and E is the second one. So B is gonna match with E. If you're in second place both times, you're gonna match each other. So if I look at B, it has 2 little lines. E has 2 little lines. And then F is the 3 and C is the 3. F and C match each other. Okay, so order matters. AB only has 1 tick mark on its side. So the side over here that only has 1 tick mark, DE, those match each other. And I knew that because AB is number 1 and 2 here. And DE is number 1 and 2 there. Okay, I'm hoping we can see that parity. This last thing here, CPCTC, definitely a mouthful, but it's a lot just to say the congruent parts of congruent triangles are congruent. So once we prove that a triangle is congruent, that one matches the other, no matter if it's turned or not, then I know that the corner will match this corner and the side will match a side. That's all that is saying. We're gonna write our own congruency statements here. So maybe my example earlier was good enough for you to just go ahead and do this. But if not, I would suggest that we label 1, 2, 3, 1, 2, 3. And I'm gonna pair them up. Angles. Angles is just one letter, just one letter. Up top it was angle A matched angle D. Here, angle J is congruent to the other number 1, angle P. Angle K, which was number 2, is congruent to the number 2 over there, which is angle Q. And lastly, angle L is number 3. It's congruent to number 3, angle R. It can be reversed. It could be R is congruent to L, doesn't matter. Sides, okay, this one's a little bit trickier, maybe. I'm gonna pair up number 1 and number 2. JK is congruent to number 1 and number 2 here. PQ. Okay. So I paired number 1 with 2. How about I pair number 1 with 3? 1, 3. JL. That's congruent to the other 1, 3. PR. I've done 1, 2 here. I've done 1, 3 there. My only other thing left to do is 2, 3. KL is congruent to the other 2, 3. QR. Second one over here, the exact same thing. 1, 2, 3. 1, 2, 3. My angles match each other. Okay? Angle W is in the leader, is in the first place position. It's gonna match with E. Angle X is in second place, so it's gonna match second place over there. And angle Y is coming up third. It's gonna match angle G. I'm gonna pair number 1 with 2, number 2 with 3, and then number 1 with 3. So 1 and 2. WX congruent to EF. Let's see, I did 1 and 2. I'll do 1 and 3. WY congruent to E, G. And lastly, I need to do 2 and 3, so X. XY, man. Congruent to FG. Okay. Alright. So down here now, given some information, given that these two triangles are congruent, find all of these missing pieces. Okay, what matches what? This is easiest if we do that number 1, 2, 3 thing that we just did. Okay, so given 1, 2, 3 matches 1, 2, 3, go and match. K is number 1. It matches with A being number 1 over here. P is number 2. It matches with Y being number 2. And then I guess the other ones have to be 3. Well, now I'm just going to go and match things up. KM was 1, 3. So over here, 1, 3 is AC. Okay. Now it's important that it's in that order. Notice this is 1, 3 and AC is also 1, 3. What I don't want you to do is 1, 3 is 3, 1. Don't tell me KM is congruent to CA. It's technically a true statement, right? Like the length here is congruent to the length here, but order matters when we name this. Confusing geometry stuff, okay? Just keep it in order. 1, 3 to 1, 3. CY. CY was 3, 2. That's gonna match 3, 2 over here. MP. PK. PK was 2, 1. It's gonna match 2, 1 over here. Yeah. Angle Y was just angle 2, so here 2 was angle P. K was angle 1, so here is angle A. And then ACY, okay. ACY is the entire triangle. It went 1, 3, 2. I need to come over here and do 1, 3, 2, KMP. Oh, that's an angle, okay. Triangle, MPK. MPK. 3, 2, 1. 3, 2, 1 over here, CYA. See ya. Yak. Okay, where we at? Yak. 2, 1, 3. So over here, 2, 1, 3. We're gonna match P, K, M. Okay. So maybe we didn't need to do the corners here, but maybe you like the visual, you can go back and match up the pieces. Your choice. Options. Given some stuff, given that you have two triangles that match each other, find the measure. Okay. Find a nicer color than that. That's a good one. Okay. 1, 2, 3. 1, 2, 3. Find each measure. Okay. BN was 1, 3. Does that help me? I need to maybe label my triangle for this one. Maybe I have to do that here. So STW was 1, 2, 3. 1, 2, 3. And over here, BFN was 1, 2, 3. 1, 2, 3. Okay, so BN was 1, 3. BN right here. It's gonna match 1, 3 over here. 1, 3, and it's a side length, right? So here, this side is worth 9 centimeters. TW was 2, 3. And that one was over here. TW was 2, 3. It doesn't have a measurement for me. So this one will though. 2, 3. 2, 3 is 14. BF, the beef, is 1, 2. So over here, 1, 2 is 17. W is angle 3, right here. Angle 3 over here, 82. Angle B was 1 over here. Angle 1 is S for 67. F was 2 over here, nothing. Over here 2, also nothing. Oh no, what do I do? Well, I know 2 of the angles in a triangle, and 9 of the triangles have 180 degrees. So I'll do 180, and I'll take away the 82, and I'll take away the 67, and I'm gonna be left with 31. All right, you can do the same thing for the next one if you want. Okay, find the measures of all of the things. You have to find the measures of 3 different variables. I'm asking you to do so much. Whatever will you do? 1, 2, 3, 1, 2, 3. Maybe label the parts. UVW was 1, 2, 3, and STR 1, 2, 3. Okay, all right. Find the values. Go. We're talking only about side lengths here. Okay, so I'm gonna start, I guess, it doesn't really matter. Maybe let's make 3 divides for 3 little math problems. 1 and 3 is worth this much here. So 3z plus 14. It's gonna match something. 3z plus 14 was 1 and 3. Over here, 1 and 3 was 50. All right, subtract the 14 from both sides. 3z equals 36. Now I need to divide by the 3. Z equals 12. Okay, I did 1 and 3. Let's do 1 and 2. 1 and 2, the side over here, 12x minus 7. That's gonna match a side over here, 1 and 2. With 1 and 2 over here, 1 and 2 is 53. Add the 7 to both sides. Divide by 12. First was 1 and 3, then was 1 and 2. Now I gotta do 2 and 3. Well, 2 and 3 over here is 57. 2 and 3 on the other side was 5y minus 33. You want to get y all alone, so you're going to add 33 to both sides, which will leave 5y all by its lonesome, and that's going to make 90. Divide by 5, you get y equals 18. You can do the exact same thing for number 7. All right, DEF equals that, blah, blah, blah. It gives you lots of sides, lots of measures. It wants you to do the things. Okay, so we can draw the pictures if we want to. We can. Maybe we don't have to. Let's see. Let's see if we can get away with it. But if you don't draw the pictures, you definitely have to label. 1, 2, 3, 1, 2, 3. Okay. It tells me DE is worth 18. DE is 1, 2. The one that matches 1, 2 is going to be JK. Does it give me JK? It does, right here. 1, 2. My 1, 2s are going to match each other. Okay. So 18 equals 3y minus 21. It's terrible, 21. We can do better than that. Oh, now I've got the y involved. Add the 21 to get 3y all alone. It's negative. You want to get rid of the negative, you add it. So it's going to be 39. Divide by 3, y equals 13. Okay. Well, I found y. Now I just need to find x. Let's see what else we got. Here's x. Here's what an x is. X is DF. DF over here is 1, 3. JL is 1, 3, 2, right? 1, 3, JL. 1, 3 matches 1, 3. Okay. Well, those are going to be the pieces that match each other. 9x minus 23 equals 7x minus 11. All right. Move the smaller x. Plus 23. 2x equals 23 minus 11 is 12. X is 6. So hold up. Because they gave me this piece of information, I used it. I used this piece, and this piece. Why in the world did they give me this piece? I didn't use it. It was to confuse you. Sometimes math problems are evil. You know that well. But they do that to give you extra information to really know that you can pull things down and figure out what is important and what is not. Okay? So maybe you don't get overloaded. Don't look at this and go, oh my goodness, there's so much. Maybe some of it's not important. Okay. Let's do another one. All right. 1, 2, 3, 1, 2, 3. It says QR is 11. That is 1 and 2. QR is 1, 2. Is there a 1, 2 and MN anywhere? No. Okay. So that's not useful to me right now. I don't know if it ever will be, but right now that's not useful. QS, that's 1, 3. QS is 1, 3. That is MP over here. Is there an MP? Yes, right here. Those two pieces are going to equal each other. Let's figure out that right now. 15 is equal to 2x plus 1. Subtract the 1. 14 is equal to 2x divided by 2. X is equal to 7. All right, that one's over. What else we got? There's a y involved in an angle. Okay. Huh. It looks like it gives me 3 angles. Okay, let's make sure that there's no double overlap here. M was number 1, angle-wise. R was number 2. And S was number 3. I have an angle 1, angle 2, and angle 3. None of those match. One, I can't do that at all. But I do know that all triangles have 180 degrees, and it just gave me every corner of this triangle. Corner number 1, corner number 2, and corner number 3. Sucker, I can figure that out now. Minus 84 minus 32. Okay, that's gonna be what? 96, 96 take away that is 64. Okay, I have 64, but why did I not I subtracted the 2 and the 3, but I didn't subtract the 1, because the 1 has the variable. I can't take 17y minus 4 away from this. That would be weird. I don't know how to do that. But I do know that whatever I have left over, that's gonna equal 17y minus 4. It's gonna be the same amount. Add 4. 68 equals 17y divided by 17. That's y equals 4. Okay, there's another way we could have done this if you don't like that way. Totally fine. Totally fine if you don't like that way. I know that everything adds up to be 180. So I could have said in a different world, 84 plus 32 plus 17y minus 4 equals 180. I could have done that. And then I could have went in and I could have combined my like terms. Maybe you like doing this way better. I'm gonna combine my 84 with my 32 with my negative 4. Because those are all the numbers that don't have variables. 82 plus this is, well, I'm gonna take the 4 away from that, make that a nice 80. 80 plus that is 112, I believe. Brain power, activate. 112 plus 17y equals 180. Then I would subtract the 112. Now get 17y equals 68. And that's the same thing that I have over here. So 2 different roads to get you to the same place.